Hello everyone, welcome to SPEC eLearn, the online learning channel dedicated to chemical engineers. Interview questions and answers in chemical engineering. Chemical Reaction Engineering Part 2. I would appreciate if you subscribe to the channel, which is striving hard to deliver valuable knowledge content for your career progress. So subscribe now before you forget. For every question, you are given 20 seconds to think about your answer. Then the answer will appear. Check your answer is correct. Wherever required, detailed explanation is given. Chemical Reaction Engineering Part 2 consists of 5 questions. Question number 6. What is catalyst deactivation? What are the possible reasons for catalyst deactivation? What is its impact on the performance of the catalytic reactor? Your time starts now. Your time is up. The answer. The catalyst begins to lose its activity as the reaction proceeds due to various reasons. As the activity starts reducing, the reaction rate decreases. So in a given reactor catalyst volume, the conversion also decreases. The nature of reactions plays a significant role in the deactivation. Deactivation is caused by poisoning, sintering or thermal degradation, fouling, mechanical damage. Poisoning. Poisoning is caused by chemisorption on active sites. Impurities in the feed or the poisons. Poisoning blocks the sites, may be reversible or irreversible. Fouling. Physical blockade of surface by carbon or coke or dust, also called self-poisoning, caused by secondary reactions of reactants and products to form coke. Usually, the activity can be regained by regeneration by changing process conditions, that is by means of heating. Sintering. Sintering is caused by thermal degradation. A bigger particle forming smaller particles due to degradation leads to loss of surface area, usually a gradual process, usually irreversible. Mechanical damage. Mechanical damage occurs during transportation and handling. It includes loading in barrels and unloading, filling in reactor bed, due to which The damage can occur by crushing and attritions. Mechanical damage can also occur during startup and shutdown of the plant. The damage occurs by thermal shock due to temperature swing. It can also be due to chemical transformation such as reduction. This graph illustrates how the reaction rate decreases with process time due to deactivation of the catalyst. Activity drop causes the reaction rate to decrease. The shape of the curve is different for different deactivating causes. Loss of surface area or loss of active sites or loss of activity due to blocking of pores due to coking and fouling. Question number 7. What is the effect of temperature on the rate of reaction? The time starts now. Your time is up. The answer. The dependence of the rate constant is described by the Arrhenius equation, which states K is equal to A exponential minus E by RT. Where A is a frequency factor, E is activation energy for the reaction, R is a gas constant, T is a temperature. This graph illustrates the relationship between the reaction rate constant K and the temperature T. As the temperature increases, the rate constant K also increases. In designing non-isothermal reactors, the Arrhenius parameters are determined from experimental rate data as a function of temperature. In order to determine the parameters, we take the natural log on both sides of the Arrhenius equation. The equation for the rate constant can be written as ln of k equals ln of A minus E by RT. To understand the impact of temperature on the reaction rate, some real data are shown in the table next. As you can observe, as the temperature increases, the value of K increases exponentially. A plot of ln of K versus 1 by T is made now with this data. You can observe from this graph, as the reciprocal of temperature increases, the natural log of K decreases. If you know the rate constant K1 at one temperature T1, and we can find the rate constant K2 at temperature T2 as per the expression given below. Ln of K1 minus ln of K2 equals minus E by RT1 plus E by RT2. Simplifying, we get ln of K2 by K1 equals minus E by R multiplied by 1 by T2 minus 1 by T1. Question number 8. What is order of reaction? Explain with an example. How is it different from molecularity of the reaction? Your time starts now. Your time is up. The answer. Consider the following reaction. A moles of capital A reacting with B moles of capital B forming C moles of capital D. The rate of reaction R is written as R equal to K into A to the power M into B to the power N. Where K is a rate constant, M is the order of the reaction with respect to A and N is the order of the reaction with respect to B. Values of M and N may or may not be equal to the stoichiometric coefficients A and B respectively. The sum of the exponents in the rate equation M plus N gives the overall order of the reaction. So the overall order of the reaction is M plus N. The order of the reaction may be an integer or a fraction. The molecularity of an elementary reaction is the number of molecules involved in the reaction. Usually, the molecularity is found to have values 1, 2, and occasionally 3. The molecularity is neither zero or fractional. It should be noted that molecularity refers only to the elementary reaction. The example shown, A plus B, is the molecularity of the reaction. Question number 9. What are the factors that affect the rate of chemical reactions? In which reactions the effect of heat and mass transfer are considered important? Your time starts now. Your time is up. The answer. Concentration, temperature, and catalyst are the factors that influence the rate of reaction. Let us understand the impact of these parameters one by one. First, concentration. At a given temperature, higher the concentration of the reactants, the greater will be the rate of reaction. Next, the temperature. As the temperature increases, the rate of chemical reaction increases. Finally, the catalyst. When the reaction is carried out in the presence of a catalyst, the reaction rate increases. The reactions involving catalysts are heterogeneous reactions where more than one phase is involved. The material may have to move from phase to phase during reaction. Diffusional resistance plays a greater role in limiting the rate of reaction. Hence, the rate of mass transfer can become important. In addition, the rate of heat transfer also affects the rate of reaction. If the heat released by the reaction is not removed quickly, temperature distribution within the catalyst will not be uniform. This non-uniform temperature distribution will lead to different rates at different points within the catalyst. Thus, heat and mass transfer may play an important role in determining the rate of heterogeneous catalytic reactions. Question number 10. What is limiting reactant in a chemical reaction? How will you identify the limiting reactant in the reaction? Your time starts now. Your time is up. The answer. The limiting reactant is a reactant that is consumed completely during the reaction. The reaction is stopped when the limiting reactant is completely consumed and no further products are made. The amount of product produced is limited by this limiting reactant, even when other participating reactants is present in excess. The limiting reactant is identified in a balanced chemical equation by comparing the mole ratio of the reactants used with that actually present in the given feed to the reactor. For example, consider the following reaction: A plus B reacting to form C plus D. The feed to the reactor consists of 100 moles of A and 20 moles of B. In this reaction, the stoichiometric requirement of A and B is that 1 mole of A reacts with 1 mole of B. Since the feed contains only 20 moles of B, the reaction will proceed till all the 20 moles of B is consumed and then stops. At this point, the reaction would have consumed only 20 moles of A. So, balance 80 moles of A is still available in the reactor. In this case, B is the limiting reactant and A is excess reactant. In many industrial reactors, one of the reactant is in excess for various reasons. The excess reactant is separated in the downstream separation section and is recycled to reactor with fresh feed for further reaction. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching.